Hello viewers, in today's class we are going to solve one very important definite integral which involves signum function, right? So here we have to solve the integral 1 over x plus 3 and signum of x square minus x, and the limits are from minus 1 to 2, right? So let us start. So let us call this integral as I, right? Now here we see that this is a rational function or the reciprocal function here, and here we have the signum function, right? So our integrand is the product of rational function and signum function, right? So let us first analyze the signum function, right? So from the definition of signum function, we know that signum of y is equal to plus 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to minus 1 whenever y is less than 0, right? So this is the standard definition of signum function. Now we shall apply this definition to this function, right? So now this signum of x square minus x is equal to, this function is equal to plus 1 whenever x square minus x is greater than 0, right? And signum of x square minus x is equal to 0 whenever x square minus x is equal to 0, right? And signum of x square minus x is equal to minus 1 whenever x square minus x is less than 0, right? So here we see that for y we have this function x square minus x, and this is a quadratic function, right? This is a quadratic function, and now let us call this function as phi of x, right? So our signum function it reads like this, right? Now here see we have the quadratic function x square minus x. So x square minus x can be written as x times x minus 1, right? So now this inequality is now equal to x times or we can write it as x minus 0 times x minus 1 greater than 0, and from this equation these are the inequalities and this is the equation. So here we have x times x minus 1 is equal to 0, and this gives us x equal to 0 and 1, right? And here we have x square minus x less than 0, so we have x minus 0 times x minus 1, and this is less than 0, right? Okay, now here our aim is to find out the intervals in which these inequalities are feasible, right? So what we will do, we'll take a number line, right? So this is minus infinity, this is plus infinity, right? Now from the theory of equations we know that x minus 0 times x minus 1 is greater than 0, then we have the two critical points, that is 0 and 1. So 0 lies somewhere here and 1 lies somewhere here, right? So now these are the two points which divides this real number line into three intervals, right? This is an important point, right? So we have this inequality, x square minus x greater than 0 and x square minus x less than 0, and we have this equation x square minus x equal to 0. So when we solve this equation, we get 0 and 1. So we plot these 2 points on the real number line. Since we have 2 roots here, the quadratic equation has 2 roots, so we have 2 roots. Therefore this number line is divided into 3 intervals, right? So 2 roots plus 1, that is 3, right? So we have 3 intervals. So the intervals are, first is from 1 to infinity, 1 to infinity, other is 0 to 1, and the third one is from minus infinity to 0, right? So we have 2 roots, and the real number line is divided into 3 intervals, 2 plus 1, 3, right? So we have these 3 intervals. Now we can easily verify that in the interval from 1 to infinity, that is when x belongs to 1 to infinity, here we have positive sign. What does this mean? It means that this inequality, that is x square minus x, is greater than 0 whenever x lies between 1 and infinity. Then we alternatively take negative sign and then positive. So plus minus plus, right? So first we'll have positive sign, then we'll have negative sign, and then we'll have positive sign, right? So when x belongs to 0 to 1, then this inequality x square minus x is less than 0, right? And when x belongs to minus infinity to 0, then x square minus x is greater than 0, and x square minus x is equal to 0 whenever x is 0 and 1, and these are the 2 points, right? So now viewers, this is how we see the sign of the inequality in these intervals, right? We can also verify these results by taking a particular value in the given interval, right? For example, if we take 1 to infinity, that is this interval, and we can take, say, x is equal to 2, because 2 lies in the interval 1 to infinity. So 2 square minus 2, that is 4 minus 2, that is 2, which is obviously greater than 0, right? And if we take any other value between 0 and 1, say half, right? So half lies between 0 and 1, then obviously the value of x square minus x, that is half square minus half, that is equal to 1 over 4 minus half, that is 4, and 1 minus 2, this is minus 1 over 4, which is obviously less than 0, right? And if we take any other value between minus infinity and 0, say x is equal to, say, minus 1, because minus 1 lies between minus infinity and 0, then the sign of x square minus x, that is minus 1 square minus minus 1, right? So we have minus 1 square is 1, and this is minus minus plus, and this is 2, which is obviously greater than 0. So this is positive, this is negative, and this is positive, right? So positive, negative, and positive, right? So this is how we assign the sign of the inequality in the given intervals, right? So now viewers, let us come to our integral, right? So now here we see that the lower limit is minus 1, right? So minus 1 lies somewhere here, right? This is minus 1, and 2 lies somewhere here. Okay, so now what we see here, we have to split this integral I into the sum of three integrals. First is from minus 1 to 0, then from 0 to 1, and then from 1 to 2, right? So we have I1 plus I2 plus I3, right? So we have three integrals, right? Okay, so now I is equal to I1. I1 is from minus 1 to 0. Here we have 1 over x plus 3, and signum of x square minus x is our function phi of x. So here we can write phi of x, and then we have the integral from 0 to 1, right? From 0 to 1, and here we have the integrand 1 over x plus 3 and phi of x dx, and then we have the integral from 1 to 2, and the integrand is 1 over x plus 3 phi of x dx, right? So these are the three integrals, right? Now when we have the value of x from minus 1 to 0, that is from minus 1 to 0, then we see that the value of phi of x is, see, in this interval we have the positive sign, right? So we have the sign of phi of x as plus 1, right? When x belongs to minus 1 to 0, right? And when x belongs to 0 to 1, right? 0 to 1, we have the sign of the function phi of x as a negative, so we have minus 1, right? And when we have x belonging to the interval 1 to 2, then the value of phi of x is plus 1, right? So when x varies from minus 1 to 0, the value of phi of x is plus 1. When x varies from 0 to 1, then the value of phi of x is minus 1, and when x varies from 1 to 2, here we have the positive sign, so the value of phi of x is plus 1, right? Okay, so therefore I is equal to, the first integral is from minus 1 to 0, then we have phi of x is plus 1, so we have simply 1 over x plus 3 dx, and then we have the integral from 0 to 1, 1 over x plus 3, and here we have phi of x is equal to minus 1, so we can take this negative sign over here, and here we have dx, and then we have the third integral, that is from 1 to 2, and we have 1 over x plus 3, and the value of phi of x is plus 1, right? So here we have dx, right? So now we have three simple integrals, right? Now here we'll make use of the result that the integral of 1 over x plus a is equal to log of x plus a, right? Okay, So we'll make use of this result, that is integral of 1 over x plus a is log of x plus a. So therefore here we have 1 over x plus 3. For a we have 3. So the value of first integral is equal to log of x plus 3, and the limits are from -1 to 0 minus, here we have a log of again x plus 3, and the limits are from 0 to 1, and then we have the value of this integral 1 over x plus 3 is again a log of x plus 3, and the limits are from 1 to 2, right? So now we can substitute the limits, and we'll take the difference. So when x is 0, we have log 0 plus 3, that is log 3, minus, and when we have x is equal to -1 here, so we have -1 plus 3, that is log of 2, right? And in the second term we have x is equal to 1, so we have log of 1 plus 3, that is 4, minus x is 0 here, so 0 plus 3 is 3, so we have log of 3, right? And then we have x is equal to 2. So when x is equal to 2, we have log of 2 plus 3, that is 5, minus when x is 1, we have log of 1 plus 3, that is 4, right? So now here we'll make use of one important property of log, which says that log of m minus log of n is equal to log of m over n, right? So therefore I is equal to this is log m minus log n. So here we have log 3 over 2, right? And then we have log m minus log n, that is log 4 minus log 3. So here we have log of 4 over 3, right? And then we have here log of 5 minus log 4, that is log of 5 over 4, right? Okay, so now we can again rewrite this expression as log of 3 over 2, and converting this negative sign to positive sign, we can take the reciprocal. So here we have 3 over 4 plus log 5 over 4. So what we have done here, we have kept these two terms as such, and we have converted this negative sign to positive sign by taking the reciprocal, because log m over n is equal to negative of log n over m, right? Okay, so now we have these three terms in log, and these are added together. So now we can use one more important property of log, which says that log of p plus log of q plus log of r is equal to log of p times q times r, right? So these three terms p, q and r are multiplied together. So here we have log of 3 over 2 times 3 over 4 times 5 over 4, right? So now we can this is p, this is q, and this is r, right? So 3 3s are 9, 5s are 45, and this is 4 4s are 16, 2s are 32, right? So the value of this definite integral is log of 45 over 32, which can also be written as log 45 minus log 32, right? So viewers, this is how we solve this problem.